Hi everyone and welcome to CodeFX and Effective Java 3rd edition. I'm Nikolai and today I'm going to tackle items 3, 4 and 5 on singletons, utility classes and dependency injection, although not in that order. As usual, you'll find tons of links in the description box, including to the GitHub repo which contains the sources that I show you here, as well as affiliate links to buy Effective Java if you don't own it yet. Now, let's see some code. Item 4. Enforced non-instantiability with a private constructor. What the hell is non-instantiability? It means that you have a class that you do not want anyone to instantiate. Why would you want that? Because it only has static methods. It's what we usually call a utility class. It provides services without state, and so all the methods are static, and then you don't want anyone to instantiate them. So in this case, I have this event bus. Apparently it's designed as a utility, which we'll discuss in a minute. And I can send events and I can receive events here, but it's written as a utility class, so this is not the intended use. And even though it still does the right thing, it is misleading to how it's supposed to be used, how the class is supposed to be used. So the better approach is to not allow it to be instantiated, to make it non-instantiable. How do you do that? You make the constructor private, because this public constructor, we get this one for free because we don't provide any constructor here. Now let's provide a constructor and let's make it private, so that nobody can use it. Event bus utility. To make this really clear, let's show an assertion error if somebody makes a mistake from within the same class and calls a private constructor, or maybe even from outside user reflection for whatever reason. Let's call a new assertion error. If that happens, and in case somebody wonders why, maybe we add comment or instantiate utility classes. Even better, we can make this part of the message. Much better. Now, we fixed the problem. Now we got a compiler error here. Now we're forced to use it as it was intended, namely as a utility class, calling only the static methods, without having the mistaken assumption that we're actually operating on an instance. But this is just the surface problem. The underlying problem is that this doesn't make a good utility class at all. Good utility classes is something like math.sine or cosine, or I have a utility where for streams, for example, where you put in methods that are not in the stream API. We take some consumer and do something with it. For example, I have a reduce to only element method that I will link to in the description box. The point is, some things are great utilities, and those are the things that are true regardless of context. Whereas this utility class actually depends on context. It's pretty easy to come up with an example. Let's say now we want to send extra important events to a different bus. Like these are privileged, let's say these are audit log events. So what do you do now? I have the send method here. Maybe I provide a Boolean flag send, which is optional, so it comes last. I could use refactoring tools to insert false everywhere in existing call sites, but that will clutter the code. So let's put in an optional parameter. Let's do the same here. Oh, not send, of course. Audit. That's what we're being asked here. So, not really better, right? So this first of all, anybody can receive privileged events, and then this doesn't really look like good API design. And the more requirements flood into this class, the harder it would be to make this work without having any state, without having any interface to implement. So this is really not a good road to go down. And the underlying reason is that this is not a context-free system that you're developing. This event bus depends on the context of the application, of configuration that has happened, of privileged events or not privileged events, or buses or not privileged buses. So this does not make a good utility class, and instead we should have done something else, and we'll cover that in a minute. Great, now I'm out of breath. Whew. Okay, item 3, there you go. Next up, item 3. Enforce the singleton property with a private constructor or an enum type. Josh is, of course, talking about the singleton, pattern, anti-pattern, whatever you think about that. Let's talk about the singleton pattern here and how to properly implement it. And of course, he's saying there should just be one instance of a singleton, so you have to prevent spurious instances being created. And the way to do that is exactly what we just looked at for item 4. You just prevent anybody else from doing that, and by creating a private constructor. So in this case, what I can do here is I can still create the event bus singleton like this, because we get the public default constructor. And as before, to fix that, we create a private constructor. There you go. And then also, like before, we could think, OK, this fixes anybody from outside the class doing this. Maybe within the class, somebody might make a mistake. So let's check that too. How do we know whether something already exists? If the instance field is not null, then apparently there's already an instance. So we want to show a new assertion error. And the detailed message, maybe only create one singleton. There you go. That would be a good way to fix this. Now, if you look at this and think, well, this is eager, maybe we can do this lazily. Don't worry, we're not going to discuss that now. That comes up in a way later issue. I think it's 86 or something. So we have time until we get there. For now, we're thinking nothing's lazy. We're just doing it eagerly, immediately. As soon as class is initialized, we're going to create that one instance. Now then, Josh discusses whether we want to do it like this, having a private static final instance field and a public static getInstance method, or just forego the entire method and just have a public static final instance field. And he says, look, getInstance, the method has a couple of advantages, but if you don't really need them, go with the field by default. I don't know. I think it just goes against my encapsulation cargo code to really have this public instance field out there. It just feels wrong to me. But beyond that, I actually agree with this reasoning that there are specific use cases which make getInstance more interesting. But I would think they apply so soon that I, by default, go with getInstance. So one of the things that he just mentions in passing that we looked in depth when we talked about static factory methods earlier is that a method has instance control. So with a method, you can decide what exactly you want to do. You can, for example, decide, and that's also one thing that he mentions, to have not one instance in total, but just one instance per thread. Or you can later decide, maybe I need more instances after all, or you can maybe have a different type here. So if you rely on just the method, then it's easier to shoehorn different refactorings into it if you need it later. Another thing that he also mentions, which I think is very, very valid, is, we get the compiler error here now, of course, is to use it as a method reference. So ignore most of this. We're going to come to serialization in a minute. There's a method I'm looking for. Here you go. This use method needs a supplier of event bus singleton. And a supplier, if you use a lambda, would use like this. We don't get anything. And then we go to event bus singleton. And if we would apply, we would just have the instance field. We would do this. Oh, this is not how you write instance. This is. Let's make it public for just, non-private for just a minute. OK, so this is the only way to do it if you have a field. That's not bad, but I think the other way is more interesting, because if you don't have the field and you want to have the method instead, then you don't have to write lambda here. What you can do instead is, not this. OK. If you don't want IntelliJ, then I'll just do it by myself. Look, here you go. As a method reference, I think that's very readable. And that's exactly one of the use cases that come up very early. So I think in general, I definitely go with a getInstance method 100% of the time. Let's go to serialization. So there's something he mentions there. There you go. So let's look at something I do here. First, I take the only instance that I have and I serialize it. Then I take those bytes, that serialization representation, and deserialize it once and deserialize it again. And then I check whether I do actually get the same bus or not. So let's run this and let's see what happens. This worked, and we get same bus false. So that means the check here came back false. So the first bus and the second bus are not the same. So that means if I have a serializable singleton, I have to do something extra to make sure that it actually stays a singleton and not people can just recreate the instance as they want. And the solution to that is you implement a method which is private object read resolve. This is one of the reasons why I hate serialization. this is not obvious at all that this method would do anything. You basically have to know. There's no interface that tells you could implement this, nothing. What root resolve does is you have the chance here to provide the instance that you actually want to use. And what we do here, we always create the same instance. So we always return the same instance. So this way, these deserializations, this method will get called and we'll always have the exact same instance. So this now should return true. Okay, that's that. The last thing he says is use an enum, even though it might be weird. And I totally agree with both of those sentences. The event bus enum that I created looks like this. Here we have the API that we're used to. And now we don't have to manually do the thing with the serialization to enforce that it's just one instance and make the constructor private, but also make sure if somebody still calls it, they get an assertion error. None of that is needed. We just have an instance enum here, and we're done. Now the JVM will guarantee all the things that we otherwise have to do manually. And to use that, let's quickly use a method for that. It's really easy. Now we want to do the same things like here. Then send and receive an event. But now we want to use the event bus enum. So let's just do that. We use instance here. And there you go. This is same thing. And now, as I said, it's awkward. It's a little bit weird to use it like that. It also reminds me of just having a public static final field, which I don't like. But that aside, it's by far the safest option. So if you use enums, if you use singletons in any way, then this might be the best way to get away by doing it correctly. If all of that talk about utility classes and singletons made your skin crawl, then you're in good company. I feel exactly the same. That's why we're now going to tackle item 5. Prefer dependency injection to hardwiring resources. For the longest time, I didn't really know what dependency injection meant. Apparently I've been doing it, I just didn't know that was the term. When I heard it, I always thought it was something way more complicated than it actually is. And we're going to use it now to prefer it over hardwiring resources, which essentially means over having the dependency established in the piece of code. We want to establish it outside the piece of code. What do I mean by that? Let's have a look. There's a class event bus user, has a method useBus, and what useBus does, it takes the event bus. Oh, no, not enough Control Z. There we go. So what this does is it uses the event bus singleton, gets that instance, and then you call send, and then maybe later receive. That means it has a dependency on the event bus, but establishes that dependency itself by calling getInstance here. And all the dependency injection does really is we're going to replace this with something like this. Event bus, and it needs a state. In Belgium at Devoxx Belgium right now, so there you go. This of course is pointless because now we're just creating one to send an event, nobody's there to receive it, and later we register receive with another one. So that's really ridiculous. Let's create a field out of that instead. Let's call it event bus. There you go. Now we have that field here, where we could initialize that field. What we could do is we could have that do that in a constructor, initialize in constructor. There you go. In this specific instance, it's still kind of pointless because now this event bus user is the only class that uses the event bus. But there are other situations where this would make sense, where you could, yes, of course, establish the dependency on event bus myself, and then I'm just going to use it within my own class. Even if that fits the profile of what you want to implement here, I still wouldn't do it. Dependency injection means taking this dependency and have it established from the outside. And that's really very, very easy to do. All you do is have a constructor parameter. There you go. Now that means this class does not establish the dependency itself. Somebody else does. Who's that somebody else? That's here. Right now this one has to create the event bus. Let's do this. Oh. There you go. Now, this might look highly academic, so where's the difference, right? Still somebody has to call new. That's right. But if you do it from the outside, you have a couple of advantages that I'm going to come to in a minute. First, I just want to address that this is all there is to dependency injection. So there could be interfaces involved, so event bus could be an interface and could have a specific implementation, or there could be a framework involved that does this for us, but none of that really is essential to dependency injection itself. All that means is If a class has a dependency on something, it gets that dependency injected instead of establishing it itself by calling new, for example, itself. That's all there's to it. So what are the advantages? The most important one is that in event bus user, there's no longer an assumption of there being a unique event bus. So if we later split this thing and we have several event buses, then event bus user does not have to know about that change. We can just keep it as it is. So we factored this assumption out of that piece of code. If we change that assumption, we don't have to touch this code necessarily. So that's a good thing. Now this assumption lives in the code calling that. And here again, maybe we would not call new here, but we have injected from somewhere outside. So this gets out of hand quickly, but we'll discuss that in a minute. Now, another advantage is that the event bus user is very easy to test. If it calls event bus singleton getInstance, then the only way to properly test that is to either be sure that the event bus is behaving as you want in your tests, or otherwise, if it doesn't, then you have to somehow mock that getInstance call, which is, depending on your setup, somewhere between very uncomfortable and impossible. This is very easy to test though. With the event bus like this, you can just pass it in. You just go during the test, you just mock an event bus or just create a new instance that behaves as you want. You just pass it in, and you can just test the event bus user and having the event bus behave as you need it for that. So that's really cool. Then the next thing is that this is also great. Yeah, if you want to have immutable classes, if you prefer classes to not change their state throughout the running system, then this is pretty good, because now you just inject the dependency when the class is created. You can have the final field here, and there you go, nothing can change with the event bus. If in some method down here you would have to create the event bus, but you also need it somewhere else, then maybe you have a field that is initially null and then later gets changed, and that's a situation where errors become, we can more easily make errors, and this way we avoid that. So that means dependency injection has these advantages. How do you go about it? As I said, you can just do it like this. This is just a plain way to do dependency injection. What you can also do is you can have setters. So you create something, you create an empty instance basically, and then you start calling setters on that, and you just set the instance that you need. I avoid it wherever I can, including working with dependency injection frameworks, because then the class is mutable, and then it just means that the state is much less clear than if you would just have dependency injection via the constructor. Like here, you immediately know where you're at and what you're doing and which state the system is in. That's good. So constructors better than setters, but there are other ways to do that. And you can, for example, have factories or builders. Remember from the other videos where I talked about static factory methods or the builder pattern? Both of them work great with this. You can have a builder which is maybe even mutable, or which builder is mutable. You have a builder where you pass it an event bus, and then whenever you call build, it would pass that event bus to the concrete event bus user that it's creating. Similar with static factory methods, you would just pass an event bus to that and would just pass it on. So dependency injection works really fine with the static factories and the builder patterns that we've seen earlier. What you can also do, and which is not uncommon at all, is to have a dependency injection framework do that for you. Because this newing can get out of hand, right? If you have a deep structure of objects, then you have to have, like, in the beginning, new like 50,000 things and then pass them on, and none of that is really very comfortable to do, and it's kind of repetitive. And when you strip out everything else, then a dependency injection framework really only does that. It just detects dependencies, it looks at the constructor and says, oh, apparently you need an event bus. Don't worry, I can give you one. Just kind of look at the event bus, or that needs a string, and then you somehow has to know how to get that string. And you can do lots of stuff by configuration. Is it a single event bus, or the serial event buses, all that kind of stuff. But it really only comes down to calling new on all of these things until you put them all together, and then you can start right away with all your instances in the state you expect them to be in, instead of having to do that yourself. That's all event bus really does. So if you're faced with utility methods or singletons, which mean that the dependency is hardwired within the class that uses them, avoid that. Refactor towards dependency injection. For example, if you have event bus singleton, then in this case, event bus could be an interface. The singleton could implement that interface. Event bus users still wouldn't know what it's using, even though up here, this won't work now because it is not an interface and doesn't implement that. But let's just assume it would. You would do this basically, or rather, you would do this. As I said, it doesn't compile here because this is not, the types don't line up, but this is how you would then pass the single event bus that you have into a class that still doesn't know that it's a singleton. It's a little bit more work if you have utility classes. In that case, you have to create the interface, and then you create an implementation of that interface that does nothing but forward calls to the to the utility class. So you have like this small facade there that wraps around the utility class, just so that the assumption that it's a single utility class does not seep into all levels of code. Instead, you just have it basically like contained into a small piece of code. And if you want to change that, then you have a much better chance of doing that minimal effort than if all the calls in the entire code base need to be changed. So that's what I prefer, definitely prefer, even if I have utility classes or singletons, still wrap that into something that abstracts that fact away to have that fact established in as little code as possible, and then pass that stuff by dependency injection into the places where it's needed. And that was that. Thank you very much for watching. Don't forget to check out the description box in the comment section, and if you subscribed, I'll see you next time with more from Effective Java. So long! Next up, item 3. Enforce the singleton property with a private constructor or an enum type. You don't do this to books.